So, hello everyone. Today we will be doing our question number 3254, which is find the power of k size subarray 1. In this question, I will be telling you what is all given. So, first we are given that in order to find the maximum element, the element should be consecutive and sorted in a ascending manner, and if they are not, then we have to return -1. The array named as nums, and it is of size length n and integer positive integer k, right? This all is mentioned here. If you read it carefully, you will be able to find this. Now, if I'm talking about this question, so two conditions are given that must be consecutive and sorted in ascending order in order to get the maximum element. Okay, let's take a array memo of size 7, which is n. And if somebody is asking you, tell me the number of subarrays. So while applying the formula n minus k plus 1, we will be able to get 5 as number of subarray. Now, how can we able to get that? Here, as we are taking 3 at once because our k is 3. So 1, 2, 4 is our first subarray in which maximum element is 4. That's why we return it as 4. And this 1, 2, 4 are consecutive also and sorted also. 2, 4, 9 are also the same. Thus 9 is here. In the third subarray, which is 496, right? This is not sorted. Hence, we return -1. Similarly, for the fourth one, it is not sorted. We return -1. For the fifth one, it is consecutive and sorted. So we return 9. Okay. Now, for solving this question, we have a brute force method also, in which first we have to check the elements here are sorted or not. If they are sorted, we have to do we have to find the maximum element, but if they are not, we have to return -1, correct? Okay. And for the I, as I are here for k times, hence the time complexity will be 0 of nk, right? Because the length of an array is n now. Okay, mostly student got time limit exceeded for the brute force method that I will be telling here. So to solve this issue, we will be following the concept of sliding window, right? Sliding window. Okay, in sliding window, we must know two conditions. The subarray and the size of an array must be fixed, right? And is in our question, subarray is given, k is given, and the k size is also fixed. It is given that it should be 3, right? For our array nums, first we took count as 0, initialize it with 0, and then by following all the array we will getting it as 4, which is our maximum element in our question, right? uh, Now you must be thinking, what is the formula to find consecutive array, right? So that is memo and nums both are array, but in our question, nums is the array, right? So you can write it like nums j minus 1 plus 1 is equal to nums of I, right? That means nums of j, right? So our fourth element, is that equal to 2 plus 1, which is 3? No, not at all. That is why we return -1. Also, if consecutive number found, right? If it is found, that means the maximum element would be present in our J pointer. So first write the code for this both methods, and you will be able to know how we did all that. So let's first write the code. Okay. As I told, we have to first find the size of our array num, right? So I wrote that. Then take a vector int, which is named as like result, in which we wrote our condition for that number of subarrays present, else return -1. Okay, then we initialize our variable count with 1 count of consecutive elements, right? After this, what we have to see is to pre-process the first window in the concept of sliding window also. By the way, this is the all brute force method, right? So int of I equals to 0, I equals to 1, initialize it with 1, I is smaller than k, and I plus increment I, then if nums of I equals to this is the condition for consecutive, right, as I told in the notes as well. So this is the condition for that, +1, right? Got it? Okay, now if this condition happened, that means consecutive count plus, but else, if not, else count equals to 1. True? Okay. Now let's take if count equals to k, equals to k, then result of 0 equals to num k minus 1. Then what we have to do is we have to initialize I by 1 and int j by k, or you can take any variable of your choice. J is smaller than n, and we write the condition where nums of j uh, equals to nums of j minus 1 plus 1, which is the condition of again consecutive, right? Plus else we have to count equals to 1, right? And after this, what we have to do is just writing the condition, which is our if condition, right? Okay, if count is greater than equals to k, okay, results of I equal to nums of j, right? And then we have to increment it, right? Remember, always remember to increment I and j, right? And then return it. Return results. First run this. Okay, compilation error might be, I think, wait. Return results, I think. Wait, my mistake, result. So compilation error. Okay. So yeah, we are able to do this, Now first comment. Okay, I will comment all the code, right, and write another method which is a sliding window method. But before that, let me discuss you something very important, which is important for all of us. Time complexity for this one would be how much? Like if we are calculating it, it would be 0 of n, and space com complexity would be, it would be constant, right? It would be constant. Now let's write another code for as the another approach, which is a sliding window approach using monotonic DQ. Okay, in which first let me first submit this code, right? Okay, let me just write another code for you. Okay, here in this one, first we, so this is the code for finding the size of an array. Then we have to take a monotonic DQ, right? DQ, in which int and DQ is here, vector int result, taking a vector, and remember it's a monotonic DQ, right? Okay, after this we have to take for int j equals to 0, j is greater than n, and then increment j, right? Increment j, correct. After that, we have to check the size of DQ also. So let's, if it is k, then we have to pop the front element, means suppose DQ size is k minus 1, right? So we will insert the jth element in the DQ, right? So I will be doing that. If DQ of size equals to k, in that case DQ dot pop front, right, means we have to insert the jth element, and when the DQ size will be k minus 1, correct. After this, what we have to see is we have to take another condition. If not of DQ dot empty, that means if our DQ is not empty, and another condition, and um, and DQ dot back, okay, which is maximum element because of the monotonic DQ, right? Something is wrong. I think I did something wrong. Yes, num equals to nums of j. I think j minus 1. This would be the condition. If this will be the condition, that we have to clear our DQ, right? Yes. Then we have to push the DQ back. DQ dot push back back of nums of j, which is nums of j, right? After this, we have to take another condition in which if condition is there, j is greater than equals to k minus 1 if dq dot size equal to k, then result dot push back dq dot back, right? Then we have to do this, else result dot push back -1, right? And then we have to also return the result. So yeah, that's all about this code. Let's hope that we will be able to pass all the test cases, which is yes, we will be. So this is our question for, and if anybody would be able to guess the time complexity, tell me in the comments, right? Here, our time complexity would be 0 of n, right? And if I'm telling you about the space complexity, that is also 0 of n. If anybody has doubt in this, you can drop a comment. I will be replying you as soon as possible, right? So bye bye. Let's and also one thing here in this question, brute force approach is not recommended because in that one a lot of people is having so much error, time limit may be exceeded, right? So sliding window concept is always recommended for such kind of questions. So yeah, that's it.